Hello and welcome to the Atlas control room. You know, the Atlas detector is built out of a variety of layers of material designed to measure different types of particles. At the far outside lies the muon spectrometer. How does that measure muons? Let's talk to my colleague Ludovico and find out. So this big detector that you have to measure very small particles and very precisely, how does that work?
We have to measure the trajectory of a particle with a precision of, let's say, 1/10 of a millimeter. This means roughly the diameter of a hair. The particles that we want to measure are called muons, and they travel through the material of the calorimeter, which acts as a filter. Generally, only the muons are coming out of this calorimeter. There are 4 types of detectors in the muon spectrometer. 2 types are used for triggering, that is choosing the events to record. The other 2 types are used for the precise tracking, as I was saying before, to measure the momentum, so the energy of the particle.
So the muon spectrometer lies on the outside because only muons can pass through all of the other material. The detector is 40 meters long, yet it's lined up to the precision of the thickness of a human hair.
The muons from space are coming from let's say, protons, electrons, and so on that are coming from sun, for example, that impinge on the atmosphere and then produce showers of particles. And between these particles there are also muons. And the muons are long-lived in the sense that live long enough to arrive to our detectors. Okay. These are one of the basic tools that we use for calibration, unless we have the machine and the accelerator.
So muons are passing through us all the time, coming from collisions from outer space. We use those muons to calibrate and align the muon spectrometer. When we have collisions, then, we'll be able to make precise measurements. So this enormous detector down there, it's not right out here, is it?
No,
Angels and Demons, it was right out there.
Yeah, no, this is 100 meters below ground.
100 meters below ground.
Yeah.
How did you build this big thing and stick it down there?
So the detector was brought down piece by piece. On average, each piece is something like 1 ton or even more. It depends on the piece. And it took something like 2 years to assemble all the detector in the cover.
Last year, in December, we had lower energy.
Yeah.
What was different about that time than what we're going to see?
We think that now the number of collisions that per second will raise a lot, and then we will have much more events, so much more muons in our case to analyze.
So the muon spectrometer is designed to measure the energy of muons very precisely. This will be essential for the discovery of new physics because muons give a very clear signal for discovery.